This lesson focuses on the introduction to scatter plots and what is correlation. You do not need to write down anything on this slide for right now. So just the definition of a scatter plot shows the relationship between two bivariate, means bivariate in IB, so I wanted to use that terminology for you, quantitative variables measured on the same individuals. The values of one variable appear on the horizontal axis, the x-axis, and the values of the other appear on the vertical axis, the y-axis. Each individual in the data appears as a point in the graph. All right, so here's an example. There is a person that we measure their height and their weight. So your height is your horizontal axis, your weight is your vertical axis, and we go ahead and put each person's measurements on here. And you'll notice when you're shorter, we can make a prediction that you're way less. So there is this thing called correlation. And there's a line of best fit that kind of goes in between them. The closer those dots are together, the stronger the correlation. All right, so let's go ahead and move on to measuring correlation. When you deal with linear correlation, there's a correlation coefficient. What I want you to write down is this. Linear correlation, the correlation coefficient R, lies between the values -1 and 1. All right, positive correlations. Go ahead and write that down. Positive correlations occur when, over time, the increases, one variable increases the other variable. So you think about your horizontal axes. If we look at that last example on the previous slide, as the person's height went up, so did their weight. This is an example of a positive correlation. Both variables increased. So the numbers that you're going to get are numbers from, and this is what I want you to write down, from 0 to 1 for positive correlations. Now, let's say there isn't a correlation. No correlation at all. Then the R value would be 0, and that's your correlation coefficient. No correlation present. So here are some examples below of different correlation coefficient values. So if your strength is very strong, like this one, R equals a +1, that means every single data point is on what we call the line of best fit. Now this one, R equals +0.8. Spread out a little bit, but it's still pretty strong, still pretty close to 1. Now R equals +0.5. See, it's a little bit more spread out here, not quite as strong. And then our last one, a 0.2. So it's getting close to 0, more spread out, but still increasing. So you'll notice the difference between when you move on the left-hand side, this is stronger, and then this way is now weaker strength. All right, next one, go ahead and write down negative correlation. The definition of negative correlation is when one increases, the other decreases. So you think about your horizontal axis is increasing, that means then your y values, your vertical axis is decreasing. The values are now going to be negative. They're going to occur in a negative value. Somewhere between, if you have R, it's going to be a little bit greater than 0 and a little less than -1. So here's -1, here's 0. Those are the numbers that will exist. So just like positive correlations, the strength of the correlation are shown here. When R equals -1, very strong negative correlation altogether. As we move along here, the closer we get to 0, the strength decreases. So you'll notice the pattern, more spread out, even more spread out, more spread out.